Hello, welcome to this introduction to the vast universal storage system and its graphical user interface. Our demonstration today is running on a small VAST cluster consisting of one 2U quad server appliance, which we call a C-box. That C-box holds four x86 server C nodes that each run one stateless front-end VAST server in a Docker container. Those VAST servers are connected to a VAST enclosure, or D-box, that has two D nodes, the redundant fabric modules that route NVMe over fabric requests from the VAST servers to the persistent media in each D-box. Each D-box holds 12 Optane 3D Crosspoint SSDs and 44 Intel QLC SSDs. When you first log into a VAST cluster, you're presented with a dashboard. The dashboard gives you a 30,000-foot view of the health of your system, including its capacity and its performance over the last 10 minutes. Let's begin our tour of the dashboard in the upper left in the capacity pane. The capacity pane shows the data reduction ratio of the system. The capacity bar shows you how much of the system's capacity is used by active data, as well as how much is consumed by data in snapshots, which we call auxiliary. And finally, how much space is free on the system. In the lower right hand of this pane, you can see the logical capacity, which represents actual data written by users. On the left, you see physical capacity, which represents how much space that same data takes up on the system after it has been reduced. You can also view the absolute values by hovering your mouse pointer over the bar chart. As we'll see throughout this video, this feature is consistent throughout the VAST UI. Hovering over any chart will display the values underlying the chart at that point in time. In the top center performance pane, you'll find three speedometers showing the bandwidth, IOPS, and average latency that the system is delivering. The bandwidth and IOPS speedometers automatically scale with the size of the cluster, so a needle pointing straight up means your system is delivering half of the IOPS or bandwidth that it's capable of. Hover over the speedometer's hub to view details about each metric. By default, these speedometers display combined read and write bandwidth, IOPS, and latency. To view separate needles for read and for write, click the hub of any of the speedometers. The top right inventory pane is where you can see a synopsis of all components comprising your VAST cluster, including their current status and health. As you can see, all of the C nodes, D nodes, 3D Crosspoint Optane SSDs, otherwise known as NVRAMs, and QLC SSDs in the system are accounted for here. If an SSD or other component fails, a red number would appear in the failed column. The column marked Other represents components which are in a changing state. This commonly occurs during an expansion or an upgrade. The lower four panes display customizable charts displaying the bandwidth, latency, IOPS, and metadata operations per second for the last 10 minutes. As you should by now expect, hovering the mouse pointer over the line on any of the charts will pop up the exact values for each parameter on the chart at that point in time. You can also see that vertical lines appear on all other charts on this page, along with their corresponding values, so you can easily correlate different metrics across different charts. You can customize any of these four charts by clicking on the Chart button in the upper right corner of the pane and selecting which data you want to display. In this case, I want to add a total latency line to the main chart, so I'll click on the Chart button and select Total Latency. Now the chart has a yellow latency line added, and if I hover my mouse over an IOPS spike, for instance, I can see what the total latency of the system was at that time. The element store page is where you control file system related configuration, including views, quotas, and NLM locks. When you select the element store page, you'll be presented with a list of views. A view describes a folder in the VAST namespace that you make available to users. Views combine the functions of NFS exports and SMB shares to provide multi-protocol access to files. To edit an existing view, move your mouse to the right of that view's row and click the pencil icon. To allow Mac and PC users access to this view using the SMB protocol, I click the down arrow on the protocols box and select SMB. If users are going to access this view over SMB, it needs a share name, so we'll enter one. Since we're changing the view from just NFS to NFS and SMB access, we'll make the share name not just NFS. The view's settings also associate each view with a view policy that defines the security model for the view. Once we've hit Update, you can see that the Just NFS view now shows both NFS and SMB under the exposed protocols. For more information on views and view policies, see the View and View Policies video on the VAST YouTube channel. The Quotas tab is where we view, create, and modify quotas on the VAST element store. This can be used either as a means to restrict the capacity used by a specific group, user, or application, or it can be used to provide reporting for chargeback or other purposes. Note that the quota demo has a state of soft exceeded. The soft quota for this folder is 190 megabytes, and the user has written a bit over 192 megabytes of data to that folder. Exceeding the soft quota generates an alert that's indicated in the upper right-hand corner, regardless of which page you're viewing in the UI. We can view the active alerts by clicking on the alert icon. If we had hit the hard limit for either files or data, the system would not only generate an alert, but also stop accepting new writes for that folder. Since that's a rather drastic action, quotas can include a grace period by delaying the system from taking action for a period of time to allow the user or admin to respond to an alert before blocking their writes. The data protection page controls the system's snapshot and data replication functions. Snapshots are controlled through snapshot policies, which are, as we would expect, on the Policies tab. Snapshot policies are used to define the frequency and retention of snapshots for each directory that you wish to protect. To manage an individual snapshot, click on the Snapshots tab. Here, you can select a snapshot and delete it if you need to recover space, or lock a snapshot to prevent it from being deleted by the system when the retention policy has been met. To manage the system's user-facing network configuration, select the Network Access page from the main menu. VAST clusters use virtual IP addresses to direct user requests to the cnodes or front-end VAST servers. Since performance in a VAST cluster is a function of compute resources on the cnodes, virtual IP pools provide performance isolation by directing users or applications to different pools of cnodes. For more information and a demonstration of how VAST server pools manage noisy neighbors, see the server pooling video on the VAST YouTube channel. To view the health of both the 3D Crosspoint and QLC devices in an enclosure, we'll go to the Hardware Layout page. There, you'll find the left side view of the enclosure and then the right-hand side. You can, of course, click on any device to get its details. The infrastructure page is where, among other things, you're able to update the software running on a VAST cluster. Just click the Update button and upload the latest software package. Select a few options and click Upgrade. The system will perform an automatic rolling upgrade in a non-disruptive fashion, all while continuing to satisfy user requests. While the dashboard gives you a 30,000-foot view of what your storage system is doing, when you're trying to troubleshoot, you typically want more details, and the Analytics page is where you'll find them. The Analytics page presents a customizable dashboard much like the popular Grafana platform. To start, let's show the read-write bandwidth delivered by each of the system's front-end cnodes. All the charts on the Analytics page are customizable, and as we'll see in a few minutes, you can save customized charts for easy reuse. You can adjust the time span covered by the chart in the upper right-hand corner, and when you see an interesting section, you can just select it with your mouse and zoom in. If you're trying to see how the storage reacted during some event, you can even specify the starting and ending times for the chart explicitly, using the convenient calendar picker. While the REST API makes it easy to write a script to read data behind these analytics workloads, often you may want to export these reports to Excel spreadsheets. So we make it easy to download a CSV. The system comes with several hundred predefined charts called analytics, which you can view directly or use as a starting point for your own custom charts. The buttons on the top filter the list to the type of components selected, making it easy to drill down to the bandwidth and latency of each SSD in the cluster, for instance. While the predefined analytics are handy, any administrator worth their salt is going to want their own customized views. And as you can see, we have some customized views already defined. The easiest way to create a custom dashboard is to start by copying an existing definition and adding the properties you want. In this way, you can dial in exactly what you want to see and easily return to your custom chart for future use. In this case, we want to add metadata IOPS to the pre-existing CNode IOPS and latency analytic. First, we select the existing analytic and click the copy button. Next, we'll change the copy's name because items named copy or copy of XYZ are a sign of a bad administrator. So we'll remove the copy of and add MD IOPS. To add metadata IOPS, expand the properties window. As you can see, there are a large number of parameters you can track, not just IOPS, but S3 metadata IOPS, to really examine how your applications are interacting with the system. To find metadata IOPS, type IOPS into the search box and select it from the resulting list. Then repeat the process until all the parameters and objects are selected. Our new analytic gets added to the list and appears on our screen with a lovely pink line added. Where the analytics screen lets you drill down and see what's happening at each CNode or even SSD level, when you want to find out who is putting that load on your system, you'll turn to the top actor screen. Here you can see the users, exports, views, and clients that are consuming the most system resources. You can set the number of actors to display. You can view the actors sorted by bandwidth, IOPS, and metadata IOPS. And then to look back to see who's generating traffic, you can step back by clicking the left arrow or click the calendar to set the time to when you saw some suspicious traffic in a log or got a complaint from the user.